Hello everyone and welcome back to my 3D platformer tutorial in Unreal Engine 5. In this video we'll be finishing off our combat system in the style of Sly Cooper. In this we will be going over the dealing damage to the enemy dummies as well as getting them to die, playing hits and sound effects, and dealing with the Softlock system, which is basically just a targeting system based on distance to our character rather than pressing a button and locking on like Dark Souls. So let me show you what I mean. So here's our first character, and as you can see, this is our closest character to closest enemy to our character. If we attack, we move in closer. As you can see, the character dies, plays a death sound. And there we go. So let me show you how easy it is to implement this into your own game. Let's get started. Okay, so first things first, we're gonna have to get a VFX pack. So if you go to the marketplace, I'll leave a link in the description down below. So all you want to do is you want to come down into your list of your library. I'll just look for realistic. And here's this realistic VFX pack. So go add to project, and I just added it to an asset library project, opened it up, and then migrated it across. So all I did was migrate the blood splat effects, and everything that came with it is all in this realistic starter VFX pack, which I then put into a marketplace folder, as this is not mine stuff. So I just like to keep what isn't mine in this VFX pack, right? So now if we go here, you'll see we've got this old cascade system, which is fine for now. In the later, once we start creating our own VFX and blood splatters and stuff, then we can replace the pre-made VFX pack. So let's get this added in, as well as changing our enemy stats, just so that we can have it separate from our player stats in case anything changes or we want to make any weird variants. So let's go ahead and start with this. So once you've downloaded the pack, what you want to do is come to your BB player and go to the end of your damage calculations of your attack combo system, and you want to put this emitter before your delay, because we do not want to delay the emitter. So drag off from your hit VFX, type emitter, and we want to get a spawn emitter at location, and then just come and select your blood splat cone. And now we need to get the location and the rotation. So we're going to use the location of this hit location, which we already used for our camera shake. So we can just drag off the pin, do that, add a rewrite node like so. And then for the rotation, we're going to get it off the normal. So we're going to make rotation from XY, and the normal is going to be both of those. And we're just going to connect to here. So this is basically just getting the forward facing normals of the object we're hitting and giving us a rotation value, which we are then putting in the rotation there. And then we just need to change the pooling method to auto release, and then we can comment this as spawn blood splatter. There we go. Okay, so click compile and save, and that's that for that, right? So now what we need to do is we need to make the enemy component. So we're just going to duplicate our BPC stats and go BPC enemy stats. So everything will be pretty much the same, but as you can see here, we're getting a player reference, which is not what we want, right? And we also don't want to set any variables or anything actually to do with adding money to the character, to the enemies. This is all stuff we won't see, or we don't want to see specifically. So we can actually just go ahead and delete all of this, as well as get rid of our references here, and click compile, save, right? So we've got obviously our current health, our max health, money, which we can get rid of since Well, let's keep it for now in case we want enemies to drop certain money when they die. So let's think about that for now. So let's open up our functions and just see if there is stuff we need to do, right? So as you can see here, we've got all this text here that we set up from our player, which is to set our health bars and stuff. So we can just get rid of all of this, and we're just going to use the actual calculations, and we'll do that for each one. So we can get rid of, we can just go straight here, delete this, get up, yep, there we go. And then increase max health, which we don't actually need, so we can just go ahead and delete everything here and just delete the function. So compile and save. So just to double check, so we're gonna get our current health and see if it's less or equal to 0. If it's not, then we tell the system that it's we need to go from subtract the incoming damage from our current health and set our current health to the new value. And then we got to check again, if our current health is less than or equal to 0, then we set all these variables. So just to check whether the enemy is dead. So go back to your BP enemy base, and then we can just add the component BPC enemy stats, right? And then you can see here we've got the enemy health and such. So once we've done that, we can just get rid of the old one. Yeah. So now that this is all done, what we want to do is we could probably put it at the start here, is we go from our BP enemy stats and we go decrease health, right? Actually, let's put this at the end. That way we can do some extra things, including the character's death. So bring this all the way to the end here, add this up here, and then get the incoming damage, which will be this damage here, and just reroute it across the top. Okay, so now we need to get a branch because we want to check if the character is dead. Let's just comment this as the decrease health. So just a thought that popped into my head, we have this increase health. So if we were to use this in the actual game, let's say if we were fighting an enemy and we disengage and we run away, and let's say after 30 seconds, we want them to start regenerating health, then we can use this increase health function. But for now, just leave it there, it's fine. And let's go ahead and create a custom event to handle the character dying. So over here, type custom event and say enemy death. Okay, so what we're going to do is we're going to go drag off our mesh, go set simulate physics, and click enable to true. So we need to change something in our mesh to make that work. So click on your mesh, so you come to your capsule component rather, and you just want to change the collision enabled to collision enabled query physics. And then also just change on the mesh here, collision enabled to collision enabled query and physics. There we go. Complete and save. And then we want to play sound at location. We're just gonna get actor location, and we're just gonna get a death sound. So I'll link to a death sound in the comments below. Okay, so there's this human vocalizations. I'm going to add it to my project, and I'm going to select my asset library again. Just change to whatever variable, version. Just add it there. Here is my asset library. You can see I've got everything I've ever used in here. So we're just going to look for the vocals, human vocalizations. Here we go. And we'll just say female C. We'll go with waves is fine. Let's just see if there's a death in here. Yeah, here we go. Yeah, that one's good. So just right click on it, go migrate. It's gonna select everything and we're gonna migrate it to our project. Okay, once that's done, you can minimize, go back to your project, open up your content browser, and you'll see now we've got this human vocalizations pack, right? So we're just gonna click and drag into our marketplace and move it there, just so we can keep it all clean. So come all the way down here. Here's our sound, so select it and just click like that. So there we go, now we've got the sound. We can obviously make it into a meta sound if we want to, or we can just change the pitch and stuff here. So random float in range, and we can go -1 and +1. So every time it plays, it's slightly different. Okay, let's set up an attenuation just so that if we're far away, it makes the sound gets quieter and quieter. So open up your content browser, go to your audio folder, and just in the main folder, we're going to go audio, sound attenuation, SA for sound attenuation, and we're just going to let this play. So in here, we're going to leave everything pretty much default. Yeah, there's nothing really we need to focus on here. We can obviously change how we want everything to be affected, but for now, this is all fine. So now just go back here and add the attenuation, which is there. Yeah, great. So we can recollapse this, and this is all the death. Then I think yeah, then we're gonna drag out, well, get a capsule component, set collision enabled to false. Well, no collision, and then we'll do the same with the mesh, set collision enabled to no collision, so that when the character falls over, when we walk into them, our character's not juttering around, or we'll just walk through them. We could also play an animation, which play animation, play montage. This will probably go at the front first, so bring it over here. So this is if we want our character to play a death animation. So let's just do that. Let's go back up to your content browser, go to characters, mannequins, animations, unarmed, attack, nope, death is great, okay. So we'll just say death front 2, so right click, well, let's see what it looks like. Yeah, that's good. Okay, so from there, just gonna right click and create montage and leave it as is, right? So then we're gonna come back to our player base and we're just gonna say death, and there's that, right? So I've set it on the uncompleted, so when the animation finishes, then we will set the physics, blah 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 blah, and then we'll say delay of say 2 seconds, and then we'll destroy that. So okay, so let's just comment all of that and say death, and then if our player is dead, we're gonna call the death function. Okay, there we go. So I just want to change how much damage our player does here. So I said it's a 20, actually 20 is fine. And enemy stats on our enemy here, it says to 50, so it will take 3 hits to kill him. So let's test if this is all working. Okay. There's 1, 2, okay, so we get an error. Let's see what we can do to fix it. So I think it might actually be okay. So I just want to double check. It might be because of this. So let's just deactivate this for now. And just connect that up like that. Just to debug. So let's check it out. Okay, so that's kind of how it would work. So it's probably the animation that's moving the character back like that. So let's just change that, because I think it would need to be root motioned. So come over here, go down to root motion. Okay, let's try it again. So we could put an animation notifier so that transition seems a bit better, but for now, that worked pretty well. So I think there might be a problem if when we take them out, we walk into the body and it causes us to jump about. So you saw it a bit there with the camera. So let's see if we can get that working. Yeah, and let's just try and get the do one. Let's do that one to there, and let's see if that works now. And there we go, perfect. Okay, so as well, if we wanted to, we can make a little particle effect that comes off their body when their body disappears, like a little smoke effect. You probably just do the same thing. You'd come to the end here and just add a particle effect just before the character gets destroyed, or just as the character gets destroyed, you put your particle effect here. Okay, so we can get rid of this, as that was causing an error. Okay. Next we can do is turn off those sword traces, as we don't need to see them anymore. So let's collapse this and go over here, select none for draw debug type. This is all fine. Compile and save. And now there we go, and show you it still works. There we go. Okay, cool. So let's move on to target lock. Okay, so now we're gonna do the soft lock-on system. So it's gonna be a similar system to old school hack and slash games like Devil May Cry, sort of where our character moves and stays close to their nearest enemy combatant. So what we're gonna do is we're gonna create a new function, and we're gonna call it move to nearest enemy. Okay. And from here we're gonna get a multi sphere trace for objects. Okay. Then we're gonna get up to location and connect it to start, and then what we're gonna do is we're gonna take the radius and connect it up here so that we have an input radius. Yeah. Okay, so then we're gonna go here and make array. Gonna put this here, and we're gonna choose pawn because we want to detect other pawns in the world. So if we put world static, it's gonna look for all static objects. So that'll be meshes, physics bodies, statics, all of those. But we want to look for pawns specifically, so we're gonna put there. And then from here we're gonna make an array on actors to ignore, and we're gonna go self, so that we're always ignoring ourself when we do this. Even then we have this ignore self checked. It's just an extra array just to a sort of fail safe to make sure we don't check ourselves. So what we can do now is we can make a for each loop. And this is just gonna run this multiple times to see all the actors in this range and add them to this for each loop array, right? And then from there we can drag out here and break the hit result. Expand this, and then we're going to get a branch up here. Just make sure that what we're hitting does have something. So drag out from here, we're going to go does implement interface, right? So let's create this interface so I can show you what this does. This will also replace our tags that we did in the previous one. So just come up to your content browser, go to interfaces and blueprint interface, BPI, enemy. Yeah, that's fine. Okay. Yeah, that's all fine. So just compile and save. Okay. So now we can come here and we can go BPI, get enemy. So what we also want to do is we want to go to our enemy AI. So back to your blueprint folder, enemy up to here, and go to class settings, and we just want to add this interface to our enemy. So go to class settings, implement the interface, add, then just search BPI enemy, compile, save. So you'll see we've got this new function here, which is what we created in the, or what comes default in the interface, which is this one here. So later on we will change this when we need to, but for now we just want the interface, right? So back to our player, and it does implement the interface. Okay. So then we need to create a new local variable. So local variables are stored within the specific function or the specific blueprint and can't be accessed from the outside. So we can't reference them in another blueprint or in a level blueprint or anything like that. So that's what local variables are. So we're going to create a new one called actors in range. And again, of type actor, make it an array. Okay. So what we're going to do now is we're going to get this archer, get it. We're going to go add and do that, and then we're going to go from hit actor to here. So basically what happens is every actor we find in the range of this radius, we're going to then check them all to see if they have this interface. If they do have this interface, we then add them to the actors in range array. Okay, compile and save. And now just coming back to the start here, get this up at the start here and clear. So anytime we run this function, we're just going to clear what's in the array currently. Connect it up like that, just so that we don't have any residual actors or anything hiding in our array. We just want to clear it so that we have a fresh batch every time. So then we can collapse this here, go here, get a branch, we can spell. Okay, just gonna do this. I'm just gonna reroute it just so it's bonita. Okay, and what we're gonna do is go here, drag out our get actors in range, get the length, and then we're gonna check if it's greater than 0. So we're just checking if our array has more than 0 actors in it. So what we're going to do is create a new variable, call it target actor, and this will just be our actor that we are going to go towards. So make it come up here and just change it to single, as we only want to target one enemy when we're doing this. So now we need to set it, and then we're gonna drag all from our actors in range and get a copy, and just set the actor, the first one in our array, as the target actor. So what we're going to do is we're eventually going to compare the distances to be the enemy that's closest to our player. That will become our target actor, so that when we attack, we go towards that target. So what we're going to do now is we're going to come here and create a new local variable called compare distances, and we're going to make this a float. And we're going to come out here and just set it. So from our target actor, we're going to drag out here and get distance, distance 2, right? Connect this up like this, and the other actor will be self. So this will be us in the blueprint. So it's just going to get the target actor distance and from ourself to the target actor, and then return that as the compare distance so that we can actually compare. So next we're going to get our actors in range again and go for each loop. And connect this up here. And from our array element, we're gonna get distance 2 again, drag out self. We're going to check if it's less then our compared distance, and then connect up to your branch. Yep, so now we're going to set our target actor. If our loop here finds that our new target is less distance than our compared distance, that becomes the new target. So that's just how that works. And then from the completed, we're just going to create a return node so that outside the function we can get this. Get the variables we need, that's the word. So we're just going to get the target actor and set that into like that. And we're just going to relabel this as closest actor. So that's going to be it for this function. So now we need to implement it. So we're going to close out of here and come back to our attack combo system. Yeah, so come over to your attack, and first what we're going to do is we're going to drag out of here, get a sequence, and we're going to just hold control from pin 0 to pin 1 because we want our function to happen first. So we just set this radius to be how big you want it, your sphere trace to be. So let's just say 800 for us. Maybe it's too big, maybe 300. And then we're going to drag out here is valid and get the question mark one. So now that we've done this, we can drag off our is valid and get a move component to node. And basically this just moves whatever component we set here in towards our target location. So I'm going to drag in our capsule component to the component tab, and then we need to get the target location. So to get that, we're going to right click on our graph and get actor location, and this will be of the self because we're trying to get our character's location. And we're going to get a node called get unit direction vector, and then we're going to go from our closest actor and get actor location. So this is just going from yeah, it's getting the location of our closest actor, which will be our target, and then comparing it to where our character is and getting that distance in X, Y, and Z coordinates, right? So then we're gonna go here and times it, and we're gonna convert this to a float, and this will be how much our character moves. So for now, let's set it to 200, and then we're gonna add it, and we're gonna get our actor location. Whoops, because we want to move in that direction. So let's connect this up here. $200 might be a bit much. Let's bring it down to say 50 just to start with. You can always adjust it a bit afterwards. Okay, now we need to get the rotation. So what all we're gonna do is we're gonna drag out from here. Let's find look. I can't spell find look at rotation. There we go. Each of these, and then just connect it up. Okay, so a small mistake I've made is this is the wrong pin connected. We want to get from our character, and then that will go to this value here, right? So we can get rid of this pin and just reroute this, because what's going to happen is we're going to get our character, get the and then we're moving our character towards there rather than trying to move our character towards there, because we already got this distance here which we're trying to go to, so we know exactly where we're trying to go to, and then we're trying to move there by a certain amount of units. We could probably put this to a variable, but that's not fine for now. So let's go ahead and move all of this up a bit. comment this as the move to soft lock system. And then, yeah, that's our combo system. So compile and save. So the last thing we need to do is just change this overtime variable. So this will be how long it takes our character to move from their original position to the new position. So maybe let's say it takes half a second, 0.5, right? So let's test that out quickly by dragging in a second enemy. One thing I'm going to do just temporarily is I'm going to go to our animation montages. I'm just going to mute the attack sound, or at least quieten it down. Because as you can hear there, it's very loud. Put this to 0.1. Okay, so let's test out the soft lock system. So we've got 2 enemies here. Yeah, nice and quiet. Yeah. So here's our distance. You can see our characters moving towards them. So I'm just going to mute or quieten down the hit sound as well. Put this down to 0.1 as well, just so that it's nice and quiet. Okay, test again. Okay, nice and quiet. Okay, over here. And then if we come over here, see a bit closer. So if I was to now go in and do it from the start again, stand here, that way, and that's our closest enemy. That's our closest enemy. So that's how easy our soft lock system works. Okay. So that will be it for this tutorial. I hope you learned something and just showed you how easy it is to implement something like this. In the next tutorial, I'll be going over creating a simpler system, sort of similar to Mario, where you jump on an enemy and that will destroy them. We can also set up the variables to be 3 jumps, 1 jump, but I'll go over all of that in the next tutorial, so look forward to that. But for now, I hope you enjoyed, and if you have any questions, let me know. Otherwise, leave a like and subscribe, and I'll see you in the next video. Cheers!